Now we are going to discuss about the LED light emitting diode. It is a heavily doped means large amount of impurity is added forward biased PN junction diode, which spontaneously convert biasing electrical energy into optical energy. Optical energy is normally obtained in infrared region or in the visible part of electromagnetic spectrum. So this is the symbol of LED. It is always connected. It is always connected in forward biased condition. It is always connected in the forward biased condition. This is the symbol of LED. An LED is always connected in forward biased. When PN junction is forward biased, electrons are sent from N region to P region and holes from P region to N region. Can you remember it? In a PN junction diode, on the N side, majority charge carrier are electrons, and on the P side, majority charge carrier are holes. When the PN junction is forward biased, electrons are sent from N region to P region and holes from P region to N region. These holes and electrons recombine near the junction. These holes and electrons recombine near the junction. On recombination, a photon of energy h nu equal to or less than the band gap between conduction band and valence band is emitted. So what is the working principle? When a PN junction is forward biased, electrons are sent from N region to P region and holes from the P region to N region. These holes and electrons recombine near the junction. On recombination, a photon of energy h nu equal to or less than band gap is emitted. As the forward current increases through the junction, that means if we increase the forward biasing voltage, as the forward current increases through the junction, what happens? More and more whole electron pairs recombine near the junction, and hence intensity of emitted light gradually increases. Intensity of emitted light gradually increases. This is the IV characteristics. This is the IV characteristics of an LED. It is in first quadrant. It is in first quadrant. It is a forward biased. This is the forward current. Current through LED is measured in milliampere because it is forward biased. It is in fault. This is the IV characteristics of an LED. So this is for infrared, this is for red, this is for green, this is for blue, and this is for white. Sometimes in the entrance exam, sometimes in the board exam, they ask to draw the IV characteristics of LED. Two important features of LED are: the color of light emitted by an LED depends on the band gap between conduction band and valence band. The color of light emitted by an LED mainly depends on the band gap between conduction band and valence band. The intensity of light emitted is determined by the forward current conducted through the PN junction. Intensity of light emitted is determined by forward current conducted through the PN junction. Choice of semiconductor material used in LED. Choice of semiconductor material used in LED. We know that the wavelength of visible light is 0.4 micrometer to 0.7 micrometer. If the wavelength of visible light is 0.4 micrometer to 0.7 micrometer, energy of light photon is 3 electron volt to 1.8 electron volt. Okay, that means in order to construct an LED or in order to get an LED which can emit visible light, so energy gap or energy gap between the conduction band and valence band should be from 3 electron volt to 1.8 electron volt. Therefore, gallium arsenide phosphide LED are used for emission the red light. Indium gallium nitride is used for blue LED. Gallium arsenide phosphide is used for red LED and indium gallium nitride is used for blue LED. Now, advantage of LED over conventional lamp. What is the advantage of LED over the conventional filament bulb? It is a low operational voltage is required and less power consumed. Fast action and no warm up time is required. Warm up time na lage. Tame gorom hoboloi time na lage. Kisuman light ase, particularly sodium light. Tumalge dekha sodium light ajikali nedekha. Sodium light agote ki korase street light hitabe use korichil. So to get the maximum intensity from that particular light, we have to wait for 20 to 30 minutes. So warm up time is required. But in LED, no warm up time is required. Action is fast and no warm up time is required. Fast on off switching capability. When we make it on, the light glow immediately, and when I switch off, it stops emitting light. So lot of applications are in the LED. LED are used in lot of different circuits nowadays. In household also, these LED are used. Sometimes one question comes, why silicon and germanium cannot be used for construction of LED? Because for the silicon semiconductor, the band gap is very, very small. It is 1.1 electron volt. 1.1 electron volt. So therefore lambda is 8c by 5. So in that case we get wavelength 11 into 2, 11.2 into 10 to the power minus 7 meter, which lie in the infrared part of electromagnetic spectrum. Or if we see for the gallium, if we see for the germanium semiconductor, its band gap is 0.72 electron volt. Therefore, energy of emitted photon is 17.25 into 10 to the power minus 7 meter, which also lies in the infrared part of electromagnetic spectrum. That means if we use silicon or germanium for the construction of LED, they emit light waves, they emit electromagnetic wave, or they emit photons of electromagnetic wave which lie in the infrared part, and we cannot observe it. We cannot observe it. Sometimes one question comes, an LED is constructed from PN junction based on certain gallium arsenide phosphide semiconducting material whose energy gap is 1.9 electron volt. What is the wavelength of light emitted? Question to enake aise, an LED is constructed from a PN junction based an LED is constructed from a PN junction based on certain gallium arsenide phosphide semiconducting material whose energy gap is 1.9 electron volt. What is the wavelength of light emitted? So H nu is equal to 5. Nu means C by lambda. So here we get lambda is 6.54 into 10 to the power minus 7 meter. Okay? The color of light emitted by a given LED depends on its band gap. The energy of photon emitted is equal to or slightly less than the band gap energy. The main characteristics of light emitted, its intensity is determined by the forward current conducted through the junction. LED usually uses a low voltage DC supply for its operation. A given LED has a safe value of forward current that it can carry. This value is normally from 5 milliampere for usual simple LED and can go up to 30 milliampere and more. A LED never used in reverse biased condition. If you want to use an LED in reverse biased condition, then it will get damaged. And another important point about the LED is the semiconductor used in LED is chosen according to the required wavelength that has to be emitted. The semiconductor used in LED is chosen according to the required wavelength of emitted radiation. Visible LED are available for red, green and orange. The wavelength of visible light is from 4 micrometer to 0.8 micrometer. Therefore, energy 3.0 electron volt to 1.8 electron volt. That the wavelength of visible light is 0.4 micrometer to 0.8 micrometer. So, therefore, energy of the photon of visible light is from 3 electron volt to 1.8 electron volt. So, clearly, the least band gap of the semiconductor for use in visible region is 1.8 electron volt. Silicon and germanium are not suitable since their energy gap is less than 1.8 electron volt. Commercial LED designed for the visible region are commonly based on gallium suitably doped with arsenic and phosphorus atoms. Okay? So for red LED, it is gallium arsenide phosphide, and for blue LED, it is indium gallium nitride. Okay? So LED is always connected in forward bias condition. If we connect an LED on the reverse bias, the LED get damaged. Okay? And what is the working principle of LED? When forward current passes through the LED, electrons are moving from N side to P side and holes are moving from P side to N side. These hole and electrons recombine near the junction, and on recombination, a photon of energy h nu equal to or less than the band gap is emitted. As the forward current increases, more and more whole electron pairs recombine near the junction, and hence intensity of emitted light also increases. And this is the IV characteristics of LED. Okay? Clear?